Hi everyone. One of FrameCE users in the Philippines asked me to show how FrameCE model the shear walls, and he gave me these skits. As you can see here, the skit shows a simple frame with a shear wall in between two columns, and there is no support at the base, meaning the shear wall cannot be designed as a freestanding column because it doesn't have footing at the base. So I'm going to show you how FrameCE model this framing system. Okay, now I prepared two models. One to the left will be modeled with a shear wall, and to the right will have no shear wall, so that I can show the difference in the lateral displacement of these two frames. Okay, and first thing I need to do is to add section properties to the material library. I will add user-defined concrete section. First, I will add a section, rectangular section in which the width is equal to the thickness of the shear wall. I will assume that the shear wall is 300 millimeters thick, and I will assume that the section depth is 600, and I will show you why I'm assuming this section later. Okay, I will designate this section as cross bracing, and then I will add one more. I will add 300 by 4 meter depth section, which will model the wall at its floor, and I will change the description to wall. I will add one more, say for example 300 by 300, and I will designate this section as dummy beam. Okay, now what I need to do is to divide these middle columns into two equal segments, and I will create elements at mid heights of the middle columns. Next, I will create elements diagonal elements for the bracing. Okay, next, exit. Now for this beams here, which I have just selected. I will assume that these beams are the dummy beams. Apply, and then I will change the section properties of these diagonal members, which are the cross bracings. So I will edit the beam properties and I will change the section to cross bracing and change the member type as compression member. Now I am modeling these diagonals as compression members because these are concrete columns. These are to be designed as concrete columns, and concrete columns can only carry compression loads. So that's why I'm assuming these as compression members. Apply, exit, and then I will designate the section properties of these middle elements at each column as the wall. Apply, exit. Now if I will show this in 3D elements, what you can see is this. So you can see that these middle elements actually models the weight of the wall. Now because these cross bracings at this point of time have weights, then I need to change the properties of these cross bracings to a weight of 0. So this is the cross bracing and this is the weight of the section per kilonewton per meter. So I will change this to 0. And the reason I have to change the weight of cross bracing to 0 is to avoid double counting of the weight, because the wall already models the weight of the shear wall. So the other members within that area must have 0 weight, which includes the dummy beam. So I will change the weight of the dummy beam to 0 as well, just like the cross bracing. Okay, now I will show the 3D section. Now this is the model. Then I will run the analysis and let us see the X displacement. Now you can see that without shear wall, the displacement at the top is very high. It's 346 millimeters, whereas with the one with shear wall, it's very low. It's only about 20 millimeters. Now the question is, how do you design the shear wall? And because I modeled the shear wall as just cross bracings, then what you need to do is just design the section of these cross bracings just like a column. and the wall areas we're in, which is not part of the cross bracing, is actually like a redundant element, which means you can just design the reinforcement using minimum reinforcement, and you can even drill a hole anywhere as long as it's not in the cross bracing. And this is the advantage of modeling this way. So I hope you learned something from this video, and if you have questions, please don't hesitate to contact me.